Hello. Okay. So, in this lecture, I'm going to discuss about change detection. Now, yes, many of you are working on this, means many of you are going to work on this particular topic. So, you should have some basic idea of this change detection. Okay. So, basically, we are going to use the satellite satellite image to do our change detection operation. Now, the satellite image is also known as remote sensing image. So remote sensing, all of you can easily understand what is the meaning. The image which is sensed remotely. Remotely means suppose your sensor is far apart from the area which you need to capture. Okay. Like we use satellite or maybe some airborne sensor or some device which is far away from the means area which you need to capture. So this process is known as remote sensing. Okay, and the image which is captured by using this process is known as remote sensing images, and these are also known as sometimes if it is captured by satellite, this is known as satellite image. So not only satellite, some airborne system also has been used to capture the remote sensing images. Okay, now. Uh, So basically, in broader sense, we'll get two type of uh, work here. Uh, but let me tell you, we are not restricted up to these two type of category. You can go beyond that also. But for the time being, we'll be focusing on this particular two thing. One is we'll be working on optical image, and we'll be working on SAR image. Okay. So I'm not going to the details of all these things, just basic brief idea I will give. Optical image means your sensor, uh, which is there in the satellite, that will be capturing the image of the Earth's surface during daytime. Why during daytime? Because in case of optical image, whatever the sensors will be used, you know what is the working principle of optical. So optical means whenever some light will be reflected from that capturing area, okay, that light will be taken by the sensor, and based on that only your image will be formed. That is the principle of optical image capturing. Okay. So why this sensor works during the daytime? Because sun is present, so some sunlight will be falling on that particular art surface which we need to capture. Okay, means your sensor need to capture. Okay, so that's why this is known as optical image. Optical means sunlight will be there, and the light will be falling on the particular area which the sensor needs to be captured, and the light will be collected. The reflected light from that particular area will be uh, uh, taken to that sensor, and the image will be formed. So that's why this is known as optical image. So some sensors are there which are generally used to capture the optical image. For example, Landsat. Landsat, this is one type of satellite. LAND Landsat. So this generally used to capture the optical image. Then ORB view. ORB view. Then we have Iconos. Okay, these not only we are not restricted up to this much. Many more sensors or satellites are there. They will be used. They are regularly using to. They have been regularly using to capture the optical image. Now you come to the other category, that is SAR image. So in case of SAR image, SAR full form is synthetic aperture radar. in case of synthetic aperture radar, it has, in case of synthetic aperture radar, these sensors have their own source. Own source means they will be sending microwaves. Okay. And that microwave signal will be sending, and it will be getting reflected from that particular area which you want to capture. Okay. And that reflection will be again will be taken by the sensor, and the image will be formed. So it means you are having some artificial source like you have some microwave. Okay. You are sending this microwave signal that is getting reflected from that particular area which you are going to capture, and the reflection is sensed by the particular sensor, and the image will be formed. So this is synthetic aperture radar. Okay. Now, why it is known as synthetic and why aperture is there and all these details I'm not going to discuss here, that I'll discuss later on. Okay, just basic idea I'm giving here. So in optical image sensor, the light source will be definitely the sun. And in this case, in SAR image sensor, the source will be the microwave. Okay, means your uh, whatever sensor you are using, it will emit microwave signal, and then it will be getting reflected from that particular area which you are going to capture, and then that reflection will be taken by the sensor, and then image will be formed. Okay, so we are going to work on these two particular categories of images. Okay. Now, if you take some example of sans sensor, which are the sensors are there. So I am giving some example. Suppose TerraSAR X. TerraSAR X. This is one of the SAR sensors. Then we have radar set. Okay, this is also another SAR sensor. So many are there. Okay, so I have given some examples. Now, uh, come to the another thing, because yeah, our objective is to discuss about change detection, but as we are going to work on the satellite image or remote sensing images, so that's why I'm giving some basic idea of this remote sensing images. Okay, after that I'll come to this change detection. Now, in when we'll be taking care of these remote sensing images, we'll be having this term resolution. It's a very important and interesting term, resolution. So what does it mean? Suppose if one sensor is having the specification of resolution of 1 meter. What does it mean? So when the sensor will be used to capture an image, a pixel of the formed image will cover 1 meter height and 1 meter width. Okay, 1 meter height and 1 meter width. Not height actually. I should not use height. Length and width. Okay, length and width. So what I'm trying to say, suppose you have used some sensor, for example, Econo sensor, which is having the resolution of 1 meter. Okay. And it has captured this image, for example. So it means each of the pixel is covering an area which is having the length of 1 meter, which is having the width of 1 meter. Similarly, the second pixel also covering an area which is having 1 meter length and 1 meter width. Okay. So it means for this particular example, if you have 4 cross 4 uh, pixels image, then definitely how much it is covering for this particular example. This is covering 1 meter, 1 meter, 1 meter means 4 meter in high, 4 meter in length, 4 meter in width, because one pixel in this direction covering 1 meter. So four such pixels are there. So it is covering 4 meter in this direction. It is covering 4 meter in this direction. So it is definitely covering an area of uh, height and width of, sorry, length and width of 4 cross 4 meter. Okay. So this is the meaning of resolution. Now we can go to the particular this thing of change detection. Uh, Now, what is chain detection? Chain detection basically it means, what is the meaning of chain detection? Okay. So chain detection basically it means to find the change in a particular area by looking at two images which are taken at two different times. Okay, this is the meaning of change detection. You are going to detect the change of a particular area by looking at by using two different images which are captured in two different time. Now, in that time interval, what changes have occurred that you are going to detect. For example, if I show you this picture, suppose this image number A was taken, suppose 10 years before. Now this 2024. Suppose this was taken in 2014, 2014, for example. Now, today in 2024, you are taking image number B. You are capturing image number B. So you see clear changes has occurred in this particular area. Okay. Now, if we want to show that changes by using some binary image, so that is your image number C. So you see here in the location where the changes have occurred that I have used white color to indicate that. And the black area or black pixels are representing the changes do not occur in that particular area. So I think you have understood what is the meaning of change. Okay, change detection. So what I have to do, I have to detect this particular thing where changes have occurred. Okay, so in order to do that, I have taken two images. One image, suppose 10 years before. This is not mandatory that you have to take images with an interval of 10 years. You can take some gaps so that changes must be there. So here, for example, if I take these two images, so here you can clearly see that changes has occurred in this particular area. Previously, it was this, you see, some lake type of thing was there. So most of the part gets filled up. Now, if you want to compare these two images, you will get this type of thing. And this white color portion will show you that particular area where the changes have occurred, and the remaining black color portion where the changes didn't occur. Okay. So we have to detect this particular thing where changes occurred, in which pixels changes occurred, and where changes didn't occur. You have to identify those particular things. So C, you can take C as the change detection result. Change detection result means I have uh, accurately identified in this particular areas changes have occurred, and the remaining areas changes didn't occur. Okay, so this is my result. Now, why these things are required? Why we are going to detect the changes? So many applications are there in remote sensing. Suppose some landslides occurred, or some deforestation happened, or suppose some natural calamity was there. So because of that, some changes happen in a particular area. Now we want to detect that thing, or we want to going to monitor the border of two different countries. Whether any changes are occurring, means any uh, line is created, or any changes occurred in that particular portion or not. Or if you want to detect some environmental changes, or suppose how the um, urban growth is going on, how the buildings are growing on, all these things, if you want to detect, definitely you have to use change detection. Okay. Now, so what are the methods you are going to use for change detection? So generally two methods are there. One is unsupervised. Unsupervised change detection. The next category is supervised. supervised chain detection. So unsupervised chain detection means you are not taking any help or manual help, or means you are not using some machine learning or deep learning type of thing. Automatically you are using these two images and using some information, you are going to identify the changes. So that is your unsupervised. Supervision is not there. Okay. Supervised means some supervision will be there where maybe you are using some labeling data to use some machine learning or deep learning based method to identify the changes. Okay. So you have two categories. One is unsupervised, where you are automatically using these two images. You are going to detect the changes, and supervised means some level data you are going to use to identify the changes using some supervision, human supervision. Okay. Now, so let me tell you, unsupervised methods, many methods are there, which many papers already published based on this unsupervised category. But nowadays, this deep learning and machine learning trend is going on. So, uh, if you try to publish some paper, so definitely people are expecting that you should use some method which is using deep learning or machine learning. Now, machine learning also people are not using. People are totally focusing on deep learning. Okay, so few works are there in machine learning also. In fact, I also published some paper based on this machine learning. Now, people are expecting deep learning only nowadays. Okay, sorry. So these are the two different categories. Now, how you are going to do that thing. So unsupervised, I'm not going to discuss here because this is not our main concern. Our main concern is the supervised, because people are expecting now machine learning or deep learning based method. So if you want to identify the changes by using some machine learning, so I'm not directly going to the deep learning. First, I will discuss about machine learning. The idea is quite similar. So first, I have to give some basic idea of machine learning. How using machine learning you are going to detect the change. Okay. So first of all, if you have to understand some machine learning, how the machine learning works. So let me tell you, machine learning can be easily implemented in your normal computer using MATLAB code also. But if you want to if you want to use deep learning, then I'll suggest to use Python. Okay, and not by using this MATLAB, it will take a lot of time, or maybe sometime it is not possible also. Now, in machine learning, okay, how this machine learning works is very simple. Suppose you are using some machine learning algorithm. So in this machine learning algorithm, you give some example first. Okay, you give some example and give its level also. Example is level. What does it mean? Suppose, in order to understand this one, let me give a very simple example. Suppose one kid is there, very small kid. Suppose 2.5 year kid is there, or 2 year kid is there. You are showing the picture of apple and banana. So, okay, suppose you have two classes of pictures. One class is apple, another class is banana. So you have multiple pictures of apple in different. Apple is you have that apple picture in different orientation, or some of the apple size are smaller, some of the apple size are bigger. So like that only you are giving some apple pictures, and you are telling that these are the pictures of the apple. Okay. Now, similarly, you have some picture of banana. Okay, and these are given in different shape, or maybe in different color. And every time you are telling, yeah, this is also banana, this is also banana, this is also banana, this is also banana. So whatever picture we are showing along with that one, we are mentioning its level. Level means you are telling this banana, either banana or this one is apple. Okay, so it means we are giving example with its level. Okay, so and After that, when you have given sufficient number of examples to that particular kid, now what you are doing? So what you let me tell you again, you are giving some, you are showing some picture of apple, and you are telling this is apple. You are showing some picture of banana, and you are telling this is the a picture of banana to a particular kid. And after that, when you have given such multiple examples to that kid, after that, what you are telling, now you are showing a new picture of apple to that kid, and you are asking, yeah, now you tell me whether this picture is of the picture of apple or banana. You are asking to the kid, you identify whether it's banana or apple. Now, if that kid is able to identify, yeah, this picture is apple or this picture is banana. If that kid is um, accurately identify that thing, so from that idea, you can come to a conclusion that yes, he or she has fully understood now. Okay, or that kid is trained now. So same example is applicable in case of machine learning also. You have some machine learning algorithm, you give some example. For example, you can take this one itself. You give some example of, give some picture of apple and give its label. You are telling, yeah, this is the label is apple, and you are giving some picture. So similarly, you are giving some picture of banana and you are giving the label as banana. So you have given sufficient example and your algorithm has trained. Now, when you have this trained algorithm that you use, now you give a new picture of apple and you ask that algorithm, you tell me whether the level is apple or banana. Now, if this algorithm is able to identify this thing correctly, so you can come to a conclusion that it has fully trained. Okay, so this is the principle of the machine learning algorithms. Okay, so many algorithms are there like random forestry, KNN, SVM, uh, some neural network. Okay, basic neural network. So these things are the example of machine learning. Okay, so you can go through the different categories or yeah, random forest I told. Yeah, random forest. So these things are the basic, and so many are there, and so many are there. So you can go through all these things to get some basic idea, and you can go to the implementation of all these things. Most of the things you will find in inbuilt form. In net itself, you will find the Python code or MATLAB code in net. Okay. Now, for our case, how we are going to do this thing? So, suppose now come to again slide number 2 and see these two picture. Now, suppose if I have the ground truth image. So, what is ground truth image? Suppose for this example, I can tell my image number C is my ground truth image because ground truth image means I have the original result. If image number A is the first image and image number B is the second image, and what is in which area my changes has originally occurred and which pixels changed didn't occur. If I can have this actual thing, then this is known as ground truth image. Ground truth. Okay, so this is my actual result. Okay, so using my algorithm, if I can get some result which is very much closer to this ground truth, so you have to understand that your algorithm is very much accurate. So 100% accuracy, it is not possible to get. Rarely you will get 100% accuracy. But what I am trying to say, what algorithm you are using to detect this change, if that algorithm is giving some result which is very much closer to the actual result, and actual result, you know, that is your ground truth. If it is very much closer to that actual result, then you can say that your algorithm works nicely. Now, so it means because, okay, I'll come to this discussion later on. Now, what I told in case of machine learning, I told you should have some level data. level data. Level means you should have, because if you can remember, I given the example of apple and banana. So you are showing picture of apple, you are telling this is the picture of apple. So similarly, so apple is your level and picture is the example. Okay. So similarly here, so many pixels are there. If I take some pixels which are locating in this particular areas of these two images, so these are unchanged pixel definitely. And if we take this particular area, you see actually some changes are there because this is shown by white color. This is your actual result, original actual result. Okay. So what you need to do, you have to take some examples of the changed area. You have to give some example of the unchanged area, because here you have two classes. One is changed class, one is unchanged class. So binary classification we are going to do. So if you take some pixels which you are taking from the unchanged area, means this particular area you can take, and some pixels from the changed area of both the corresponding image. And if you tell which are the pixels you have taken from the change area and which are the pixel information you have taken from the unchanged area, if you give the level also. Okay, for example, if it is still confusing, let me give another example. Another way I need to explain this thing. Suppose, first of all, you are taking some pixel number one from here, 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 here. So suppose 10 pixels are there from the corresponding location. So if this position and this position, if you are taking these are the definitely corresponding location. These are the corresponding location I am considering. Though my drawing is not perfect, but let me consider these are the corresponding pixels. So if I take the corresponding pixels information in a combined way, then this suppose my example number one from the unchanged area. So example number one information I have given with the level, this is unchanged. Then example number two, also unchanged. Then this unchanged, three unchanged, four unchanged. So such type of 10 examples, suppose I have given from the unchanged pixels. And I'm telling also the level is unchanged. And likewise, I can take some examples from this particular corresponding location of the image where the changes has occurred. This to this, this to this to this. So these 10 examples I can take from the change location and I can give the level as change. Now use this data to train your as any algorithm, any machine learning algorithm. So if you give sufficient example to your machine learning algorithm, it will be trained. So here, for example, I am giving 10 example, though it is not sufficient. You have to give at least 150 examples with its level, then it will be trained. Now, when you have the trained this algorithm, then you can use that now for a new example. Suppose I'm taking some pixel from this particular location. Suppose I'll take some pixel from this particular corresponding location. So see, these examples I didn't give during training. Okay. Now this example I am giving to the this problem I am giving to my trained model. Now whatever this trained model I have, now I am giving some, I am asking some question to the trained model. You tell me whether this pixel is representing change or unchanged pixels. So if it is able to say this is unchanged, it means that your algorithm working nicely. And if I give some example from some changed location, which I didn't use during my training phase, that also I can ask, because I need to ask both the categories, changed as well as unchanged. And if it is able to identify this, yes, this changed, okay, it working nicely. So it means your machine learning algorithm will have two phases. One is training phase, where you will give some examples with its level. Then the second thing is the testing phase. Testing phase means you will give example without their level and you will ask them to find out the level. So I think now things are clear to you. It has two phases. One is training. In training, you are giving examples with their level. When you have given sufficient examples, you have the train model. Now you will use the train model here and you will give some question to the train model and you will ask that model, you find out the level. That is known as testing. Okay. So I think that the things are clear to you now. So you have two phases. One is training, another one is testing. Now come to the main discussion, how to do that. Okay. Now how to do that. This theoretical understanding you have understood, but how to do that practically? So for that, you again take these two examples, or let me these images again here. Just give me some time. Okay, so we can take this example. So how to use some machine learning algorithm? Suppose I am using SVM, support vector machine. So what I need to do, I have to give some example of the corresponding location information I need to give from the unchanged area of the both images. Okay, and giving some examples of the changed area with the level. I have my train model now. The train model I'm going to use to ask some questions. So give some, sorry. So ask some problem which you didn't use in the training phase. I use this example for the testing phase and ask your train model, you find out the level, whether it is taken from changed location or unchanged location. Okay. Now how you're going to do this thing practically. So what you need to do, first of all, you have to, okay, you have to take some information of the corresponding pixel of both the images. Okay, what information we are going to do? So generally, people what they are using for each of the pixel, they are considering 25 cross 25 neighborhood. Okay, 25 cross 25 neighborhood. It will contain the information of that particular pixel. Why not that pixel directly we are using, not the intensity of that particular pixel we are using? Sometimes a particular image pixel may have some noise. So because of that, it is not accurately, it will not be able to detect the changes accurately. So that's why we are not only taking this pixel information, whereas we are taking is 25 neighborhoods information means we are considering is this pixel surroundings or neighborhood. And that gives second 5 cross 5 areas. So we'll have in total 25 pixels for a particular point or pixel of this image. So similarly, for the same corresponding location, we can take this information for the second image also. Okay, so here you will get the information of 25 pixel. Here you will get the information of this 25 pixel of the second image. So you combine these two things. Now you have the information of 50 pixels. So that will be used as your example, what I said that now, or feature that is known as feature. I told you, if you can remember here, I told you give some example with this level. What example means? The correct meaning of example is feature. You are giving the feature of this particular point by considering 25 neighbors. So here also 25 neighbors, 25 25, you are putting one after another. It means concatenation you are doing to get 50 point intensity values. Now, this is known as feature of this corresponding point. So same thing you can do for this point also, same thing you can do for this point also, same thing you can do for this point also. So you will have some feature and you know the actual, because if you have this figure number C, you have to see whether it is black or white. Black means definitely that particular location is unchanged. So you can give the level also. So this level is unchanged because that is showing black. So for the second feature also, you can give the level of unchanged. Just you need to check whether it is black or white. Black means unchanged because this third picture actually it is having either 0 or 1. 1 means changed, 0 means unchanged. So if you are finding 0 in the third picture of the corresponding location, so you need to give the level of unchanged. If you are finding 1 in the corresponding location, you need to give it changed. So the first 10 examples, whatever we have given, that is from the unchanged location. So each of the level will be unchanged because you will see in the corresponding location, all these things are coming 0. Okay. Now, after that, similarly, you have to do the same thing for the changed pixels. You have this change pixel, you have these white areas. From the change pixel also, you have to consider this 25 cross 25 neighborhood, and you have to concatenate the corresponding pixel information 25, 25, and it will become 50. And this will be called as feature. Now you give the tag of or level of changed. Okay. So you have feature, you have level. So give it to your SVM and train it. Now, when you have trained model, you use some example which you didn't use during the training phase and ask your train model whether it is giving change or unchanged. So these things are available in, you can go through YouTube or Google. Many such examples are available. You try to implement it. Now here, what thing I told just now, here you will get some type of difficulties. People generally, as you are beginner, will get some difficulties. Let me tell you why. The reason is, as you are starting from the corner pixel, because what I told you, find out the feature for each of the corresponding location. Suppose this is my image number 1. This is my image number 2. I need to generate the feature. Suppose take this example 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Oh, entirely it is getting added. Sorry. 1, 2, 3, 4, 5. So, for example, these are the unchanged pixel. We are taking some example. These are the unchanged pixels of the both image. And these are the changed pixels. Okay. One more row I need to draw. Yeah, fine. Now, what you need to do, I told you have to first take the information of its 25 neighbors. 25 neighbors means if you're starting from this location, you do not have anything in the left side. So how to get this 25, means 5 cross 5 neighbors. So what you can do at the initial stage, if I put some zeros in the boundaries, okay. Now I have 25 neighbors now. Is it 25? Yes. So first of all, you need to do zero padding for both the image so that these corner points do not make any problem. Okay. Then for each of the pixel, you take its 25 neighbor of this first image. So for the first point, point number one, suppose this is my point number one. So I have 25 pixel information. Just take the intensity value. So similarly, you do the same thing and get this 25 pixel value, intensity value, and put it in the right side of the first 25 pixel information what you got for the first image. Same thing you will get for the second image corresponding location that you put in this next location in order to make it 50 length feature and give it the tag of or level of unchanged. So you have to do the same thing for the next pixel. So for this also you'll have some 25 pixel information, put it here. This is for feature number 2. And for the second point also you have this 25 point feature. You put it here in the back side of this one. Now it will 50 feature. This is also unchanged. So likewise, you do for all these examples, these are unchanged, and similarly do the same thing for the changed. Give all these examples with this tag or level to your SVM algorithm. And when you have this train, now you give some example which you didn't give during the training phase and ask the algorithm to find it out. Suppose here, these are the examples we didn't give in the training phase. This. So you give this example to the training phase and ask the algorithm to find it out whether it is changed or unchanged. So this is the thing you need to do. So I think you have understood how to make this 50 feature. You have to take the intensity of this value. You have to take the intensity of this value, concatenate one after another, it will make 50. Because now if you have the confusion here, we are having 5 cross 5 means 25. Because if we have a 5 cross 5 matrix, is it not possible to generate some array of 25? Yes, you put it one after another. 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Then the next row, you put it in the next. The next row, put it in the next row, put it in the next. So it will be a length of 25 for the first image. So for the second image also, it will be a length of 25. 25, 25. In total, it is 50. Okay. So we can stop our discussion here. I think you have some basic idea how to implement this thing. Thank you.